Okay. I hope we have completed 3 experiments. Okay, I think we have completed half adder, then full adder with using VHDL as well as using Verilog. Okay, then we have done 4-bit adder also, full adder. Okay, so now in today's session we are going to perform experiment that is a 3:8 decoder. Now what is mean by decoder?
Decoder is a combinational circuit which decode the encoded data.
Decoder is the combinational circuit, yes, and it decodes the input data. Okay, so that means suppose you are having 3-bit input, then you will get 2 raised to 3, that means 8 outputs. Okay, so if you are having n number of inputs that are present, then you will get a 2 raised to n number of outputs at the output of that circuit. Okay, so here Avinash, stop presenting. So decoder, that is uh, having a job which is opposite to encoder, and it is a combinational circuit that converts n lines of input into 2 raised to n lines of output. Okay, so we are going to perform experiment related with 2 raised to 3 to 8 uh, line decoder. Okay, so for that truth table will be like this. Okay, so if we are having inputs that is a x, y and z, and outputs that is from D0 to D7, these are the 8 outputs. So for the decoder circuit we are assuming that only one output will be high at a time. Okay, depending on the input signal. So that means if suppose we are having input that is 0 0 0, then D0 line will be high and all others that will be at a 0 logic level. Then if it is the input is 0 0 1, then D1 line will be high and all others that will be at a 0. So for 0 1 0, D2 will be high, others 0. For 0 1 1, D3 will be high. For 1 0 0, D4 will be high, and for 1 0 1, D5 will be high, 110 D6 will be at high logic level, and 111 D7 will be at a high logic level. That means if we look at the each of this output signal, then we can have the Boolean expression for this output, that is D0 is equal to x bar into y bar into z bar. That means x bar, y bar, z bar, that is equal to that is nothing but the Boolean expression for D0. For D1 we will have the Boolean expression as a x bar, y bar, z. For D2 it will be x bar, y, z bar. For D3 it will be x bar, y, z. For D4 it is a x, y bar, z bar. For D5 it is x, y bar, z. For D6 it is a x, y, z bar, and for D7 it is a x, y, z. Okay, so these are the Boolean expression for each of these output. Okay, now using these Boolean expressions we are going to write a VHDL code for this 3:8 decoder. Okay, so uh, here we are going to have a data flow modeling for this. Okay, so let us have a program for this. So let us start with a new project. Just give name to this as a decoder 38. Next, okay. So all those specifications that you have to check it carefully and then proceed. So let us proceed as all these specifications that we are going to keep it as it is. Here you will find the project summary where we have kept device that is a Spartan 3E family that is a Spartan 3E and device that is XC3S500E package BQ400 and speed -4. Okay, we are using a top level source type that is a HDL, then simulator that is a ISIM which is useful for VHDL and Verilog, and preferred language that we are going to use that is a VHDL. Okay, so let us finish this. So here in a hierarchy, you will find your project. Okay, so right click on that and then new source and VHDL model. Okay, so let us give name to this as a decoder 3_8. Okay, next. So let us change this name of the architecture as a data flow. You can keep it as a behavioral also, no issue. And then we have to specify here inputs and output ports. Okay, so if you don't want to write it here, you can skip this and you can just click on next. Okay, and finish. So here you will again get a skeleton for your program where library declaration part that is there. Okay, and here now you will find that in a entity it is just a blank. Okay, so that means what ports are not declared here. You are just having the entity name and then end of the entity because we have not specified any inputs there. So now you can specify the names here for the input as well as output port. So port, okay. Now we have the ports that is X, Y, and Z. These all are input ports. So input and each are of the std underscore logic type. Okay, then semicolon and we have D0, comma D1, comma D2, comma D3, D4, D5, D6 and D7. These all are the output of std underscore logic type. Okay. All ports that we have declared, and so complete the bracket and semicolon. Okay, so this is the uh, entity declaration part of this uh, project. Okay, so here we have 3 inputs and 8 outputs. That is a 3:8 decoder will have 3 input ports and 8 output ports. Now here you can see that this std underscore logic that is in a lowercase while this is in a uppercase. Okay, but as we know that VHDL is a case insensitive, so if you are writing it in a uppercase or lowercase, that will not affect on the performance of this program, so we can have it in any case. Okay, now let us write architecture for this. Okay, now, as we are going to use data flow modeling, so here we will not have any process. We will just have the expression for this. Okay. So, what will be expression for D0 now? So, here we have to assign a Boolean expression to the output D0. So, assignment operator that is a less than equal to D0 less than equal to. Now, what will be expression here? काय लिहिणार एक्सप्रेशन इकडे D0 चं एक्सप्रेशन काय आहे D0 इज इक्वल टू x बार y बार z बार. आता ते तुम्हाला VHDL मध्ये लिहायचं म्हणजे तुम्ही कसं लिहिणार मग
not of x or not of y or and sorry ma'am
and not of
not of y
y and
and not of Z.
not of Z. Okay, semicolon. Then D1 that is assigned to
Not of X and not of Y and Z.
Z. Okay, D1,
Ma'am, D2.
D2 not of X,
X and Y not of Z.
D3
Not of X and Y and Z. X and not of Y not of Z. X and not of Y and Z.
Yes, Vishakha. What is going on?
X and Y and not of Z. X and Y and Z.
Okay. So this is our architecture for our decoder, 3S to 8 decoder. Okay. So let us save this and then synthesize. So let us first check syntax. So syntax is correct. Then let us check view RTL schematic. Okay. So here you can see a RTL schematic for this decoder. Okay, so that actually this is nothing but a block diagram for the 3S to 8 decoder. But if you double click on this, you will find a complete schematic. Okay, so you can zoom this and then you can find a get level diagram for this. Okay, so this is a 3S to 8 decoder schematic. RTL schematic. You can also check for technology schematic. So here this is a technology schematic which is with a buffers. So as we require here input as well as output buffers whenever we are implementing it. So net level net list that should be generated here. So for this we have this technology schematic. Okay, so you can check this. If you click on this, you will find this is nothing but a um, get level schematic only. Okay, so here this is lookup table for the third input. So here it is a you can see this connections. You can check for the truth table also. So whenever 100, that time only it will be giving high output. For others, it will give a low output. So this is a D4 one. Okay, D3. This is a D4, then D3, D5. If you check for D5, it is not like a truth table. Will be for 110, it will give a high. So now let us go for writing a test bench. So I'll close this RTL schematic as well as technology schematic, and then I'll just right click on your VHDL program. Now we want to write a test bench, so click on VHDL test bench and give a name, file name to this test bench. So I'll give this as a decoder 3_8_TB, because I want to differentiate this program from your actual VHDL program, as this is a TB, that is a test bench. So I'm just giving a name as a _TB. Then next, next, okay, and then finish. Okay, so this is a test bench. So here you can find a library declaration part, then entity declaration. Here entity, that is ports are not declared in this. So as we are calling here a component, that is a decoder 3s to it, which we have already done. So that we are having. So port declaration of this component, that is XYZ, and D0 to D7 will be there, and then end of the component. And then we are going to initialize first all the signals, input signals, to 0. Okay, so these are initialized, and then initial value for all these signals, that is made 0. And then also we are declaring here a output signals, that is a D0 to D7. Okay. Whenever we are calling any component in a program, so that time all the ports that should, that means all the input values that should be available in terms of signal, and that is why we are declaring these signals. So these, all these inputs and output, that we are declaring as a signals. Okay, and as we don't want this clock signal for this, so I'm going to delete this, and then beginning of this stimulus architecture here. So we are instantiating the unit under test. So for unit under test, we are going to map all the ports of this unit under test to the decoder 3s to 8, which is nothing but our actual component. So प्रत्येक जे त्याचे पोर्ट्स आहेत ते आपण याच्या पोर्ट म्हणजे युनिट अंडर टेस्ट, आता जो आपण युनिट टेस्ट करणार आहे त्याचे जे पोर्ट्स आहेत ते आपण डिकोडरच्या पोर्ट्स बरोबर मॅप करून घेणार आहेत. सो मॅपिंग साठी आपण ऑपरेटर वापरतो इक्वल टू greater than. Okay, so x is mapped with x, y is mapped with y, z, and d0 to d7 to again d0 to d7. ओके, हे सगळे पोर्ट्स जे इनपुट पोर्ट्स आहेत आणि आउटपुट पोर्ट्स आहेत ते आपण काय करतोय, मॅप करून घेतोय. आता याच्यामध्ये आपण दोन्हीसाठी सेमच नेमिंग यूज केलेला आहे, त्याने काही फरक पडणार नाहीये कारण आपल्याला जस्ट ते मॅपिंग करायचं आहे. So we have used the same names. Okay, this is a by default skeleton that you are getting. म्हणजे याच्यामध्ये जे तुम्हाला मिळतं ते बाय डिफॉल्ट आहे, तुम्हाला काही करावं लागणार नाहीये. So already automatically all these ports that are mapped. Okay, so that we have done. Then there is a clock process. As we don't want this, I will again delete this. Okay, and then stimulus process. So we have first initialized all the signals x, y, and z to 0. So we will first have this reset state. Okay, this is nothing but a reset state. So all the signals that are we are making it to 0. So we are going to hold this for 100 nanoseconds. So wait for 100 nanoseconds, and then after that we are going to initialize certain values to all these inputs. So x, so that means we are giving a stimulus. So as we want to give either 0 or 1 value, so it should be in a single quote. So let us give this value as a 1, or I will make this as a 1, 0, sorry, semicolon. Now I will make y, that is equal to 0, okay, and z, that is I am going to assign to 1. So what I have done? I have set x, y and z to the value 0, 0, 1. Okay. Now as in the initial case our value was 0, 0, 1, that means D0 bit output bit will be high. Okay. Now we have made it 0, 0, 1, that means D1 bit will be high. Okay. So now again I am going to wait for 100 nanoseconds. So I will copy this as well as this part also I am going to copy, and then I'll just paste it. Okay. So I'm going to wait for 100 nanosecond. I can make this smaller also. Okay, I'll make this smaller. So I will just keep it as a 10 nanosecond. Okay, and then I'll make y bit as a 1 and z as a 0. That means my sequence is now 0, 1, 0. Okay, next thing. Again, I'm going to make this as a 1 and z is also 1. So x is 0, y is 1 and z is 1. Okay, then next, that is 1, 0, 0. Then next is 1, 0, 1, 1, 1, 1, 0. So whether we have completed all these input combinations. So 0, 0, 0 already completed, then 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Okay. So now again we have this wait statement which is related with the clock. So we will again delete this. Okay. And then the end wait. Okay. So after this it is going to wait for the continuous time period, and then as we don't want this process. Okay. So this process that we want actually. So this is related with the stimulus process. So end of this process and end of the architecture. Okay. So let us save this. And now just go for the simulation, click on your test bench program. Okay. And then here you will find in the processes, now you will get a ISIM simulator, expand that and check for the behavioral check syntax. Click on that so that it will get behavioral check syntax will be there. So it is completed successfully. So now let us check for the simulate behavioral mode. Okay. So we got this window, that is a open ISIM window, and then just zoom to full view. Let us again zoom. So here you will, if I click on this, you will find that whenever x, y and z all are 0, d0 is high. Okay. If I click on this, for a 0, 0, 1 combination, d1 is high. For 1, 0, 0, d2 is high. For 0, 1, 1, d3 is high. Then for 1, 0, 0, d4 is high. For 1, 0, 1, d5 is high. And for 1, 1, 0, d6 is high. And for 1, 1, 1, d7 is high. Okay, so that means here we are getting the results as per our specifications. So this is a tested and it is tested okay. So we got the result for this 3:8 decoder. Okay, so this is the simulation of 3:8 decoder using VHDL language. Okay, so now let us have one more exercise. Okay, आता आपण काय केलं की आपण 3:8 decoder केला. So now you tell me a program to write a VHDL code for 2:4 decoder. Okay, so just similar it will be there. So you just tell me. So I'll just create a new project now, decoder 2_4. Okay, next, next, finish. Okay, I'll just click on this and right click, new source, VHDL module, then decoder 2:4. Next. Okay, I'll just click on next and finish. So 2:4 decoder म्हणजे त्याच्यामध्ये इनपुट पोर्ट्स किती असणार आहे?
2.
2. Okay, so in the entity we'll just declare this port. Okay, names to this ports x and y. Okay, so these are the input, type is std_logic. Okay, and output ports, how many output ports will be there?
4. 4. D0
Tell me
to
the
D3.
name. D0, D1, D2 and D3. All these are the outputs of the type std_logic. Okay. All the port declaration part is completed. So bracket completed and then semicolon. Okay. So this is the entity declaration part. Now architecture declaration. So now tell me the statements here. D0 that is assigned to
Not of X and not of Y.
not of x and not of y. Okay. Now Utkarsha, tell me statement for D1. What is Boolean expression for D1? Utkarsha. Shweta. Hello Shweta. श्वेता जमदाडे आहात का? प्रज्ञा.
Yes, ma'am.
What is Boolean expression for D1 in 2:4 decoder?
Not X, Y.
Not x. Okay, not sorry. not X and Y. Okay. Then for D2, Vidya, what is statement for D2? Snehal, Yogesh, Giridhar, Prathamesh, Chiliseth, Satyajit, सत्यजित मुळे आहात का क्लासमध्ये? Okay, his friend, tell him to contact me. सकाळच्या सेशनला पण मी त्यांना कॉल केलं होतं, त्यांनी रिस्पॉन्ड नाही केलं. त्यांचं जे कोणी फ्रेंड आहे ना, त्यांना सांगा त्यांना मला कॉन्टॅक्ट करायला. ओके, काय येणार आहे D2 साठीचं स्टेटमेंट मग?
X
Who's going to
and
tell?
not
Yes,
X and not of Y.
X and not of Y. Okay, and D3?
X and Y.
Yes, yes, and this is the program. Okay, that we have finished. Okay, end of this behavior, and then let us save this. Just let us, we know our syntax is correct, but still we are going to check it. Okay, we have compiled it and completed successfully. Check syntax. Then let us see RTL schematic. So this is the schematic, and if you click on this, you will get a this gate level circuit schematic. Okay, so here this is nothing but X bar, Y bar. This is X bar Y. Then this is a X, Y bar and X bar. Okay, so this, that is a 0 1 0 0 1 1 0 and 1 1. Okay, so all these outputs that you will get here from D0 to D3. Okay, so now let us close this, and then now what we are going to do, we are going to write a test bench for this. So right click on the project or this VHDL code and select source type as a VHDL test bench. Give a name to this decoder 24 underscore TB. Next summary, you can check for this, and then so this is a library part. Okay, then this is the entity part, then component declaration, all the ports of the component you can check for this. जे आपण तिथे डिक्लेअर केले कंपोनंट मध्ये होते ते जसेच्या तसे तिथे घेतलेले आहेत. ओके, त्याच्यानंतर इनिशियली एक्स आणि वाय इनपुट्स दॅट इज असाइन टू 0 these signals and all these output signals that are also assigned here. आपल्याला क्लॉकची गरज नाहीये, रिमूव्ह करूयात. ओके, त्याच्यानंतर port mapping. So here all these ports that are mapped of this unit under test to the component decoder to for ports. Okay, then this process that we don't need for the, which is for the clock, so that also we are removing. And then this is the stimulus process. Okay, so let us wait for 10 nanoseconds only, and then we have the x, that is equal to assigned value 0 initially, and y that we are going to assign to the value 1. Let us copy this so that we can save our time. Okay, I'll paste this for 2 more times. Okay, and now I will change this. This is the 1. Okay, actually no need to paste it. Okay, we will make this final also 0. So 1, and again we will go to the reset state. So I'll make this as a 0, 0. Okay, then remove this statement which is related to clock. So I'll just remove this also. So end of the process, the stimulus process is ended here, and then end of this architecture. Okay, so save this, then click on iSIM simulation in the view, then click on your test bench program. Here in the process, you will find iSIM simulator, expand that and check for the behavioral syntax. Check syntax, check syntax, that is completed successfully, and then now you can go for the simulate behavioral model. So initially you can see here when x is 0, y is 0, d0 is 1, d1, d2 and d3 all are 0. Okay. Here when x is 0, y is 1, d1 is high, and d0, d2 and d3 all are 0. Then next is when x is 1 and y is 0, d1 and d0 and d3 all are zeros, and d2 only is at a high. Then after that, for 1 1, x is equal to 1, y is equal to 1, d3 is 1 and all other outputs that are 0. And for again when x is 0, y is 0, d0 is 1 and all others are 0. Okay, so this is a 2:4 decoder. ओके, सो इथे आपण काय केलं, डेटा फ्लो मॉडेलिंग यूज केलं आपण दोन्ही, म्हणजे 3:8 डिकोडर साठी पण आणि 2:4 डिकोडर साठी आपण या सगळ्या जे आउटपुट्स होते त्याच्यासाठीचे जे बुलियन एक्सप्रेशन्स आहेत ते लिहिले, आणि त्याच्यानंतर म्हणजे ते असाइन केले, आणि त्याच्यानंतर काय केलं आपण टेस्ट बेंच मध्ये प्रत्येक इनपुटचं स्टिम्युलस दिलं, म्हणजे आपण प्रत्येक वेक्टर डिफाइन केला आणि त्याच्याप्रमाणे आपण चेक केलं. आता आपले सगळे आउटपुट्स ऍज पर आवर specifications मिळतात, that means whatever code that we have written, that is correct one. Okay, so that we have checked using this simulation. Okay, so this is about our fourth experiment, that is VHDL code for 3:8 decoder. Okay, in that also we have seen 2:4 decoder. ठीक आहे, कुणाला काही डाऊट आहे याच्याबद्दल? आता इथे आपण काय केलंय, या सगळ्यांसाठी आपण म्हणजे प्रत्येक जो पोर्ट आहे तो सेपरेटली डिफाइन केला, म्हणजे एक्स आणि वाय सेपरेटली घेतलं, d0, d1, d2, d3 हे पण सेपरेटली घेतलं. त्याच्याऐवजी तुम्ही डी म्हणू शकता फक्त त्याला, आणि तो वेक्टर म्हणून कन्सिडर करू शकता, आणि मग परत मात्र प्रोग्राम लिहिताना तुम्हाला d(0), d(1) असं करून तो तुम्हाला प्रोग्राम लिहावा लागेल. अदरवाइज ऑल अदर थिंग्स आर दॅट विल बी सिमिलर. म्हणजे तिथे तुम्ही वेक्टर म्हणून पण घेऊ शकता, म्हणजे ती बस असेल आणि मग तुम्हाला त्याच्याप्रमाणे आउटपुट मिळते. ओके, काही कुणाला डाऊट आहे याच्याबद्दल?
नो मॅम.
ओके, समजलंय सगळ्यांना? क्षितिजा?
Yes, ma'am.
ओके, समजलं?
हो.
Okay. So I think you are attending from since from the last week. हो ना?
Yeah, from the 24th
Okay.
August.
Okay. So if any doubt is there, you can ask. You can go through the study material that is shared with you all. Okay.
Yes, ma'am. The
Then
CR has provided me the link. I'm going
okay.
through that.
Okay. So कुणाला काही डाऊट असेल तर विचारा, अदरवाइज लेट अस स्टॉप फॉर टुडे.
No doubt, ma'am.
Okay, so then let us stop for today, and then we will continue in the next session with the next part of the theory. Okay, so till then, bye. ओके, आणि तुमचे काही डाऊट्स असतील, मी ज्या लिंक आज शेअर केलेत झायलिंग सॉफ्टवेअरचे, ते तुमच्या शीटमध्ये पण शेअर करते, म्हणजे तुम्हाला ज्यांना डाउनलोड करायचं आहे, ज्यांच्याकडे लॅपटॉप पीसी अवेलेबल आहे ते करून घेऊ शकतील. आणि त्याच्यानंतर तुम्हाला इन्स्टॉलेशनला काही प्रॉब्लेम येत असेल तर तुम्ही मला मेसेज करू शकता. Okay, so you can leave this meeting for today. We will meet in the next session now. After.
Thank you, ma'am.